Good morning, everyone. Welcome back. Thank you for joining. I am Steve,
And I'm Scott.
and together we're Backyard Musings, the Science and Technology channel.
And today we're talking about space, and we love that topic. We've talked about it many times, and we're gonna talk about it again this morning. So here we go.
This is how Heavenly Father makes it happen. It takes millions and billions of years. This is how He makes it happen. While
Yeah.
surveying distant worlds beyond our solar system, researchers unexpectedly obtained the first direct images showing objects colliding within a nearby star system. In the early life of a star system, space can be a chaotic crash zone. Pieces of rock and ice, such as comets and asteroids, frequently collide, sometimes breaking apart and sometimes sticking together. Over time, this constant jostling helps transform, and we're talking a long time, helps transform the original dust and frozen material in a stellar nebula into planets and moons. The biggest smashups are thought to be uncommon across the hundreds of millions of years it takes to build a full planetary system, occurring only about once every 100,000 years. Would you like to know more?
That's just a season, right? So we
Yep.
talk about the season. All right. Even so, astronomers now identify the aftermath of two major impacts in just 20 years around the nearby star Fomalhaut. Fomalhaut?
Fomalhaut. Yeah.
Fomalhaut. That could mean researchers happen to catch two rare events by chance, or could suggest that massive collisions are more common during planet information than models predict. The events, first seen in 2004 and again in 2023, marked the first time scientists have directly imaged collisions between large bodies in any planetary system beyond our own. Cool.
Quote, we just witnessed the collision of two planetesimals and the dust cloud that gets spewed out of that violent event, which begins reflecting light from the host star, said Paul Kalis, adjunct professor of astronomy at the University of California, Berkeley, and the first author of the report. Continuing his quote, we do not directly see the two objects that crash into each other, but we can spot the aftermath of this enormous impact. So it's the dust, the light reflecting off the dust that they're catching.
Yeah. Over 10,000, tens of thousands of years, he said, the dust around Fomalhaut would be sparkling with these collisions, like twinkling holiday lights, almost like when we see maybe like the Milky Way, some parts of the Milky Way where it almost looks like it's cloudy and stars.
Yeah.
There's so many stars, right? That's kind of we get that
Go
look.
ahead, keep on to the next paragraph, too.
Okay. Paul Callis began looking for a dusty disk around Fomalhaut in 1993, aiming to spot debris left behind their planet, behind after planets form. Fomalhaut lies just 25 light years from Earth and is relatively young at about 440 million years old, making it a useful stand-in for what the solar system may have resembled early in its history.
That's 25 light years. That is pretty close. Using NASA's Hubble Space Telescope, he later confirmed that the star is surrounded by such a disk. In 2008, he also reported a bright point of light near the disk that appeared to be a planet and was the first exoplanet candidate directly imaged at optical wavelengths. Following the standard naming convention, he labeled it Fomalhaut B.
That planet discovery has now turned to dust. What we thought was a planet was likely the dust cloud kicked up by the collision of planetesimals. Quote, this is a new phenomenon, a point source that appears in a planetary system and then over 10 years or more it slowly disappears, he said. It's masquerading as a planet because planets also look like tiny dots orbiting nearby stars.
Based on the brightness of both the 2004 and 2023 events, the colliding objects are at least 60 kilometers across, what's 37 miles, at least 4 times larger than the object that collided with Earth 66 million years ago and killed off the dinosaurs. Objects of this size are referred to as planetesimals, objects similar in size to many of the asteroids and comets in our solar system, but much smaller than a dwarf planet like Pluto.
Well, at least they're calling it a planet again. Fomalhaut is much younger than the solar system, but when our solar system was 440 million years old, it was littered with planetesimals crashing into each other, Collis said. Again, that's another quote. Going on with the quote, that's the first time period We are seeing when small worlds are being cratered with these violent collisions or even being destroyed and reassembled into different objects. It's like looking back in time, in a sense, to that violent period of our solar system when it was less than 1 billion years old, unquote.
The 2023 Fomalhaut observations are discussed in a paper published in the journal Science on December 18, 2025. Quote, the Fomalhaut system is a natural laboratory to probe how planetesimals behave when undergoing collisions, which in turn tells us about what they are made of and how they formed, said Kalis's colleague Mark Wyatt, a theorist and professor of astronomy at the University of Cambridge in the United Kingdom. Continuing the quote, the exciting aspect of this observation is that it allows us to estimate both the size of the colliding bodies and how many of them are in the disk, information which is almost impossible to get by any other means.
He estimates that there are about 300 million objects around Fomalhaut, the size of the ones that collided to generate these bright clouds of dust. That's a lot. Holy cow, 300 million. Previous observations of the star detected the presence of carbon monoxide gas, which indicates that these planetesimals are volatile, rich, and therefore very similar in comparison to the icy comets in our solar system, he said.
Fomalhaut, located within the southern constellation Pisces Austrinus, is 16 times more luminous than our sun and one of the brightest stars in the sky. After Calis began observing it with HST in 2004, he discovered a large belt of dusty debris at a distance of 133 astronomical units AU from the star, more than 3 times the distance from the star as the Kuiper belt is from the sun in our solar system. And AU is the average distance between the Earth and the sun, or 93 million miles.
To Calis, the belt's sharp inner edge suggested it had been sculpted by planets. After a second observation in 2006, he concluded that a bright spot in the outer belt, visible in both the 2004 and 2006 images, was, in fact, the planet. He acknowledged at the time that it could be a very bright dust cloud caused by a collision in the disk, but the likelihood of that seemed very low.
Calis was able to schedule 4 follow-up Hubble Space Telescope observations of Fomalhaut in 2010, 2012, 2013, 2014. So that took a long time to schedule to get on the telescope. It tells you that there's like a waiting line for this kind of stuff, you know?
Right.
It's crazy.
So Elon, man, build another one of these. Build 2 or 3 of these.
In the last, however, Fomalhaut B was nowhere to be seen. 9 years later, after 3 failed attempts to image Fomalhaut with HST, he obtained a new image that revealed another bright spot not far from the first, which is now referred to as Fomalhaut CS1 for a circumstellar source 1. Based on its location, however, the new spot dubbed Fomalhaut CS2 could not be a reappearance of Fomalhaut CS1. That's getting confusing.
Yeah.
Because of the 9-year hiatus between the 2014 and 2023, it's unclear when Fomalhaut CS2 appeared.
In the new paper, Calis and an international team of astronomers analyzed the 2023 image of Fomalhaut and a subsequent, though poor, image obtained in 2024, and concluded that it could only be light reflected from a dust cloud produced by the collision of 2 planetesimals.
Calis noted that at first Fomalhaut CS1 moved like an exoplanet, but by 2013, its path had curved away from the star. This type of motion would be possible for very small particles being pushed outward by the radiation pressure of the starlight. The appearance of CS2 supports the idea that CS1 was, in fact, a dust cloud.
Calis compares these events to the dust cloud generated in 2022 when NASA's DART, which is the Double Asteroid Redirection Test, mission slammed into the moonlet Dimorphos, which was orbiting the asteroid Didymos. The cloud around Fomalhaut is about 1 billion times larger, the team estimated. Wow. These are crazy numbers.
Calis has been awarded time over the next 3 years to use the James Webb Space Telescope near-infrared camera and the HST to observe Fomalhaut and track the evolution of the cloud to see if it expands in size and determines its orbit. It is already 30% brighter than Fomalhaut CS1. Additional observations in August 2025 confirmed that CS2 is still visible.
Yeah, we like the James Webb Space Telescope.
Yep.
We talked about that device many times. In anticipation of future space missions to directly image exoplanets, Callis cautions astronomers to be on the lookout for dust clouds masquerading as planets. Quote, these collisions that produce dust clouds happen in every planetary system, he said. Once we start probing stars with sensitive future telescopes such as the Habitable Worlds Observatory, which aims to directly image an Earth-like exoplanet, we have to be cautious because these faint points of light orbiting a star may not be planets. These guys, I wonder if these guys have any free time. Are they already on it? These guys are always on this stuff because they miss something. They take a lunch hour and they may miss something.
Well, it's like everything's recorded from the space telescope. They record it and take photos, and then now, in between the year that it takes to get the next appointment, they're studying all these photos and making observations of it and publishing papers. Making opinions. So.
Yeah, not much free time. Anyway,
give me your money is what they're saying.
Yeah, well, they probably do need money. These guys do. So, anyway.
All right, folks. Thanks for joining us. We'll catch you in the afternoon.
Take care, everybody. Have a good morning. We'll see you this afternoon.